On my 00 gauge model railway, I built a canal with a working lock. A number of people have asked me to explain how the mechanism works. Basically, there are three transport systems, one above the lock, one below the lock, and the third in the lock itself. There are two gearboxes that open and close each pair of lock gates, and a further gearbox that raises and lowers the lock. Each of the three transport systems are built around plastic 12mm ID square U-channel. All of the parts are 3D printed, and the FreeCAD and STL files are available from the comments below. Any small 3D printer can be used. The water is 3mm Perspex painted underneath with the suitable brown-green colour to represent canal water. The whole is mounted on a base made of 18 by 50mm timber. Cosmetically, the lock gates and lock walls that I used are available from langleymodels.co.uk, and they also do a range of scale narrowboats. Let's look initially at the transport system. Each of the three transport sections is constructed in exactly the same way. Each section is built around a length of plastic 12.5mm ID square U profile channel. The length of the sections above and below the lock can be as long or as short as required. The length of the U channel for the lock section should be 26 to 27 centimeters to create a prototypical lock. A 6mm tooth belt runs in the bottom of the U channel with the teeth facing upwards. A carriage with a matching tooth pattern and a powerful magnet runs in the channel on top of the tooth belt. At each end of the U channel is an end bearing and a cover with two pulleys. The covers go over the top of the pulleys like this. Obviously that one has to face the other way around. In the middle of each section is a motor mount and a cover and a 10 RPM motor. 10 RPM gives a realistic canal boat speed. The motor mount contains two pulleys and a gear. Now the two end bearings have been installed onto the U channel, and the motor mount in the middle and the motor attached onto the motor mount. The two pulleys on that end and the two pulleys under there on that end, the two pulleys and the gear in the middle. So now is a good time to check the length of the piece of belt that you need by running the belt around the gears, around the drive gear, and then if you put them tooth to tooth and hold them with a clamp, then you'll get the correct length of the belt. They don't want to be too tight. This is the transport system for the upper level above the lock, and in this case it has still got an 18mm base to which it's screwed. It's got a simple support at one end. At the other end it has a double support like this, which is this piece here, which bolts onto the end bearing, and there's a bolt that goes into the wooden base. When you put everything together, it looks like this. The three transport systems, one above the lock and one below the lock, and between them the third system in the lock, which goes up and down. The toothed belt drives the carriage, which in turn pulls the boat along. I've started using 10mm tooth belts to get better grip and drive. The boat enters the lock from the top section. A magnetic detector positioned in the lock triggers a relay that stops the three transport motors and switches power initially to close the top gate. Within the top gate is a gearbox with a limit switch which stops the gate motor when the gate is closed and switches power to the lift mechanism to lower the lock. The system is designed for a difference of about 1 inch or 25mm between the high and the low sections. This is equivalent to a scale drop in the lock of 6 feet or just under 2 meters. A limit switch detects when the lock has reached the lower level and switches off the lift motor and switches power to the lower gate gearbox to open the lower gates. Again, within the gate gearbox is a limit switch which stops the gate motor when the gates are open and switches power back to the transport motors so the boat leaves the lock. We'll get to the detail of the electrics in due course, but there are two parallel wiring systems. A red wiring path drives the transport system from the high section to the low section. A second green wiring path drives the transport system from the low section to the high section. To reverse all the DC motors, the polarity of the green wiring is reversed. In this case, there is a switch to reverse the polarity of the power and to change from the red wiring to the green wiring so that the boat will go back from the low section through the lock to the high section. The sections above and below the lock can be as long or as short as you want. At each end of my model canal is a bridge, and beyond that at each end is a turntable that turns the boat around and changes direction so that the boat returns through the lock and will continue to go back and forth until it's switched off. The model of the canal is based upon St Catherine's Lock on the Way Navigation, just south of Guildford in Surrey. The Way Navigation is owned by the National Trust, and it's basically a river. The rule on the Way is that you leave lock gates open when you leave. This is different from the rule from most of the canal network, but does make the sequencing of the action through the lock much simpler. It would be possible to close the gates after the boat has left and then reopen them again as the boat approaches, but this would greatly complicate the electrics, which are currently fairly simple. The system to operate the lock gates consists of two identical gearboxes. Each one consists of a motor mount, four gears, a middle section which has the limit switches built into it, a switch bar and a cover. The motor mount and the four gears are mounted together. The midsection goes over the top, and then the switch bar goes into the middle gear so that goes backwards and forwards to show the limit switches, and you've got adjusters on either side, and then finally the cover goes on the top. The lock gates are attached to the top of a brass square rod which actually goes into the gears and is held at the top in a prototypical way by a collar which is attached to the side of the lock. The lift mechanism consists of a gearbox which is mounted underneath the chassis, and it has a 62 RPM motor mounted in the middle which connects with a gear, and then one gear on either side of that, and these gears have an M12 half nut embedded in them so that as they rotate, they both rotate the same way, and they will then rotate the nut, which will then screw up and down these M12 bolts. They are mounted in a spreader bar, which is again a piece of 12 millimeter ID U-channel, and the tops of the bolts have to be thinned off, to be cut off so that they fit inside the channel, and they are mounted with these two nuts onto the channel so that as this motor turns and these gears turn, then this whole bar will rise and fall. Then there are two M6 bolts connected to the spreader bar which connect through to the mounts, and these mounts attach to the actual transport mechanism, and by being able to change the length of those you can adjust the tilt of the spreader bar so that as the motor turns, the gears turn, they move up and down, they push up and down on the bolts, which pushes the spreader bar, which in turn pushes the mounts and actually moves the whole transport system. When the motor and the gearbox are assembled, the cover will eventually go on the top, and that is held onto the bottom of the chassis by 6 bolts. The M12 bolts will go through the M12 nuts and will be pulled down. The spreader bar is attached onto the 2 fittings there by M6 bolts, and you can adjust the relative height of the 2 sides of the lock that way. If you turn the lock section over, you can see the limit switch is attached to the end bearing on the upper end of the lock section, and the other limit switch will be on the lower end. The perspex at the upper level overhangs the lock mechanism, so that as the lock comes up, the limit switch in the middle left is triggered by the perspex, and then that stops the lift motor and opens the gates so that the boat can come out. As the lift drops the lock, the perspex hits the limit switch, and that turns off the lift motor and starts the gate to open so that the boat can leave. Now we need to start looking at the wiring system, which looks a bit complicated but is actually relatively straightforward when you start breaking it down. The system is powered by 12 volts DC, and the first thing is a direction switch down here, which is a 3-pole double terminal switch. If you have an automatic turnaround, you could make that into a relay. But what that does is it switches between the 2 different wiring systems. There are 2 wiring systems running in parallel. One of them are color-coded red, and the other one is color-coded green. The red system is designed to drive the boat from the high end to the low end, and the green system is designed to drive the boat from the low end to the high end. The green system, in order to get all of the DC motors to work in the opposite direction, the polarity is reversed, so that direction switch not only tells you which direction to go in, whether you are going to go on the red system or the green system, but it also reverses the polarity of the green system. When the system starts up, the transit systems will be running. All 3 transit motors will be operating, and they will continue to operate until the boat comes to one of the magnetic detectors. So there's a magnetic detector here for the boat when it's on its way down, and that is in the red system. And there's another magnetic detector here for the boat when it is on its way up, and that is in the green system. Those magnetic detectors trigger this relay. The relay switches off the transit motors and then starts the sequence of gates and the lift. If it's the red system, then the sequence starts to go down here to the gearbox down here to close the gates. When the limit switch is there, it transfers the power into the center section, which will then drive the lock downwards. And when the lock has got all the way down, it transfers the power to the lower gate, open the gate, and when it opens the gate, the gate is fully open, then the transit system starts up again and the boat leaves. Similarly, if you're going the other way in the green system, then the power will come into here initially, will close the gate at the bottom. It will then transfer the power to the middle, which will raise the lift until it hits the limit switch, which point it transfers the power to here, and that will then open the top gate, and then the transit motors will start up again and the boat will leave. This is the main circuit diagram, and probably the easiest thing to do is to do a screenshot and print it off. But we'll look at each section individually. But you have the direction switch, and then you have the transport stopping switch, which includes the magnetic detectors in the lock. And then you have the upper gate, the lock lift, and the lower gate, and then the transit motors. Between each sections, you have a red and a green and a black wire, so that 3 wires between each section that run from one section to the next. The direction switch is a 3-pole double throw switch, which is fed by 12 volts DC, and it switches between the red and the green wires. If it's the green, it reverses the polarity between green and black. If you have a straight 9 terminal switch, then that will be the wiring for it. This is the wiring for the transport stop relay. So you have the 3 wires coming in from the direction switch. You have the 2 magnetic detectors which trigger the relay, which is a double pole double throw relay that switches between the green and the red system and also turns the motors on and off. Coming out of this system, you have 3 wires that go to the top gate for the red system and 3 wires that go to the bottom gate for the green system. Each of the gate systems and the lift system are wired in basically the same way. So if you're looking at the red system that is running from high to low, the boat, it will stop in the middle of the lock, and then power is fed into the red system, which will then, because this is normally closed, will trigger the motor to close the gates behind the boat until this limit switch operates, at which point the power is then transferred to the red out, which is then into the red in for the lift, which will then power up the lift motor to drop the lift because it's going down until the limit switch is hit, at which point the power will come out of the red, go into the bottom gate, which will then operate the bottom gate motor until the limit switch is operated, and then the power will come out, and that will then start the transit system going. And between each section, you've got the 3 wires, the red and the green and the black. So red going from high to low and green going from low to high. Green works exactly the same in the opposite direction. If you want to have the gates open before the boat arrives and close after it leaves, the way that you can do it is this. There are normally 6 wires that connect into the gearbox. And what you have to do is take those 6 wires and put them into the normally closed terminal of 6 parallel relays, and then connect the gearbox to the common of those 6 parallel relays. So when the relay is off, then it works normally as if the 6 wires were just connected together. But when the relay is turned on, then it will take the power from the motor, reverse it through 2 diodes in order to drive the motor backwards on the gate motor. So as the boat moves across the magnetic detector, it fires the relays, the gates open, and then the gate will go in normally because the relay is off and now the gate is connected as it would normally be. When the boat leaves the lock, as it comes up to the magnetic detector, again it will trigger the relay and close the gate behind it. Because the time that the magnet is close to the detector is too short, you have to put a delay timing relay into the circuit so that the relay stays on long enough for the gate to close. Of course, that is the circuit for only one gate. You would need to repeat the whole thing for the gate on the low section. This is the circuit diagram for that system, so that the magnetic detector triggers the on delay off timer, which triggers the 6-way relay to isolate the gate gearbox, and then the motor drive power through a pair of diodes either closes the gate if it's open or opens the gate if it's closed. Whether or not you need this will depend to a certain extent on the era that you are modeling. So if, for instance, you are modeling a more modern era, which is basically eras 6 to 11 from the mid-60s onwards, then you're looking at a leisure boating situation, and the rule in general is that you must close the gates after you leave them, when you leave the lock. If, on the other hand, you are doing eras 1 to 5, so any time before the mid-60s, particularly in the steam era, then you're dealing with a working boat situation, and the working boatman left the gates open so that it would be ready for the next boat coming through. So that is the mechanism for making a working model canal lock. This method will work just as well with narrow locks for a single narrowboat or wide locks capable of taking a narrowboat or wider barges. The width of the lock will be dictated by the width of the gates when closed at 30 degrees. The gate gearbox motors run at 2 RPM. Langley models make locks walls, lock gates for wide or narrow locks, as well as scale narrowboats. They also do the same in N gauge and O gauge. I'm sure that other manufacturers' products are also available. The transport mechanism works for any scales. For O gauge, you may want to make the lock deeper, which just means making the supports taller. For both O and N gauge, you may have to adjust the width of the gate gearboxes. To make the perspex more slippery, use Carrom, C-A-R-R-O-M powder on the perspex and velvet on the underside of the boat. The strength of the two magnets in the carriage and the boat need to be strong enough to pull the boat, but not too strong to cause too much drag. All the belts seem to stretch over time, and so it may be necessary to put some extra pulleys in to retension the belts and stop them slipping on the drive gears. Copies of the FreeCAD and STL files for all the parts are available by sending an email as indicated in the description below, and the parts list is also in the description below. Questions are always welcome. Enjoy your modelling.